we said with all of our previous webinars, we will send out the slideshow and the video links to your lecturers, and you can get all of that information through the lecturer. And even our previous videos, you can get that information through your lecturer. Okay, so like I mentioned, just our agenda for today is just some sketching basics. Then Irfan is going to go over to simulation, how to get started with your simulation so that you guys don't actually use the Simulation Express, but you can use the full suite of simulation, because with your SEK, the student premium, or the license, the educational edition license that is in the networks, in the laboratories, you actually have access to the full suite of simulation, also full suite of flow, plastics, everything. So please don't use the Simulation Express, as there's lots of limitations in the Simulation Express product. Okay, but I'm just going to start off with some sketch basics. Just going to show you the basic principles of where you can get the sketching and what you can do with the sketching. How to start a 2D sketch, also how to do 3D sketches, just what's the difference between the two. And then also just the sketch options that are available. And then using 3D sketching and splines. And if you have any questions, please ask in the chat box. You can just ask the questions straight from there. Irfan will answer your questions, or I will answer your questions. Okay, so, and then also I'm going to show some splines and some sketch dimensioning, how you can actually dimension between arcs and circles, how you can click and create variables. So we'll just go and look at all of those basic ones for you. Okay, let's jump straight into it. Again, if you have any questions, feel free to ask the questions throughout the webinar, and we'll also just have a question and answer session at the end of the webinar. Okay, so one of the main things that you can do in SolidWorks, so you have your sketch tabs. Like I've mentioned last week, if there is some of the tabs not actually showing, you can just go and activate it. So I'm just gonna stop this. Okay, so first thing, very important, is in SolidWorks you have three different options. So you have your front plane, your top plane, or your right plane. And remember that you can either work on the normal to the front plane or normal to the back of the front plane. So technically your front plane is two planes. It's your front and your back. Your right plane is your right and your left, just depending on which way you're looking at it. And then your top plane is your top and your bottom. Again, just the way you're looking at it. So always be careful and always keep a lookout for the trimetric, the triad here on the left and bottom screen. The reason why I'm saying that is, if I select my front plane and I make it normal to, sorry, I selected the right plane now, but the right plane is also a good example. So you'll notice that your Y is going up and your Z is going to the left. So anything you draw to the right will go into the negative Z. Okay, again, just keep, but if I make it normal to the right plane again on the other side, now my Z is pointing positive to the right, and then my top is still going up. So what I'm just want to show you is that you must always just be sure that when you're drawing, that if it's a first angle or a third angle in your part environment, you must always look at the triad with the coordinate system. Always make sure you go from your 0 to your positives, positive Y, positive X, positive Z. Okay, so always just keep that in mind. So what we're focusing on today is our sketch options. So the sketch options is the second tab, and with SolidWorks, SolidWorks is intuitive, where you can actually either select sketch and then select the plane you want to sketch on, or the other way around. So you can actually select the plane and then say, okay, I'm going to draw a sketch on it. Or you can even say, okay, I want to start with a boss, then do the sketch. You can do it either way around. There's no right or wrong way. So how I normally do it is I click on my plane I want to sketch, and then you'll see there's a pop-up. So the pop-up that comes up is sketch. If I click on that sketch, notice now that it'll actually make a normal to that plane. So that is a setting in SolidWorks. So every time you draw a new sketch, it'll always be normal to. The reason why I do that is if I want to draw like this, and I want to draw a square. That it's quite difficult if this thing is not normal to know actually how the perspective is making it. So always Control 8 to normal to, or you can do Control 7 for isometric view. Just a few shortcut tips that I'm just showing you as well. But if you want to add that setting directly, you can go into your options, and then under sketch, the first option is auto rotate view, normal to the sketch plane, and sketch creation on sketch edit. So you can also just think for yourself. So if I want to draw on a piece of paper, I normally put that straight up in front of me and start to draw. It's very difficult to have it at a 30-degree angle and then draw something, because it will just look wrong, even though it's the same dimensions. Okay, so that's just a tip that you can do. So maybe put on this first option for auto rotate view. Then just another tip that I can also give you is you have options for screen numeric input. So in SolidWorks, we always want to have specific values for my sketching. So if it's a square, it should be 100 by 100. So the option is you can either take the small dimension and tell it, okay, this line you are 100, and then the other line is also 100. But you'll notice now that as more you use SolidWorks, you'll see that it's actually a tedious process to every time go and create it. So you can have this enable on-screen numeric input, and with that, create dimension only when the value is entered. Okay. So look at this. So I'm going to select my front plane. I'm going to make a sketch. I have all of my different options here in the first side. So we're just going to run through a few basics of them. So I'm just for this example, I'll go through them all now. Again, if you hover over it, it'll actually show you exactly what is going to happen, how you should draw the sketch line. Also, even though it's very small to maybe see that, but let me zoom in for you. Notice that all of the sketch entities has got 2 dots. That one also has 2 dots. That one maybe has 3 dots. So if I go and I click on my drop down, I'll have more information on the specific ones. The 3 dots or the 2 dots actually say how many times must I click to create this block, or how many times must I click to create this circle. So if it's 2, you'll understand that it's just those 2 clicks, or a center one, again, it's 2 clicks. So for this, I'm going to select a center rectangle. And you'll also notice when you go into the properties, it'll actually exactly show you. There's one click, 2 click, 1 click, 2 clicks. These ones at the bottom, for example, has 3 clicks. So just keep that in mind. And for this, I'm just going to use this center rectangle. So first click, you'll see that it shows you there in the middle. Drag it outwards and then click again. But now notice that I have that sketch numeric input. So here on the left hand side, I can just go and type in 100, press tab, it'll go to the next one. I can press 100 again and click enter. So I don't even have to click because I already gave it the specific dimensions that it should be. And you'll notice now that this becomes black. Black in SolidWorks means it's a fully defined sketch. So if I give this to someone else to go and design, there's no other way that that person can design this except 100 by 100. So the reason for that is if you get into practice and I take my sketch and I give it to someone else, and that's not a fully defined sketch, there is ways of how they can incorrectly go and design that. So always try and get your sketches in a fully defined word. You'll also notice in the bottom of the screen, it'll actually tell you it's a fully defined sketch. Okay. So that was just a basic of a rectangle. And then I have now my line items or my circles. Again, if you want to have more information, you can just click on the button below or just hover over it as well. It'll give you information. So this sketches a circle and then click to place the center of the circle, then drag and release. Okay, I'm going to select that again. Again, notice that you have the option. So it's either a 1 click or a 2 click or a 3 click. And very, very important, there's an option here that actually states, is the diameter the dimension or is it radius? Always make sure that you either use radius or diameter. It's very important. There's a massive difference between a 50 radius and a 50 diameter. You don't want to go and order a pipe that is a 50 radius if it was only a 50 diameter. Okay, lots of costing involved in that. So what I'm going to do, I'm just going to create a center circle. Again, I can just go outward. I can now either go and click and it will just keep it as it is. And if I now want to go and dimension this, I would actually have to click on it, say smart dimension, or in the left-hand top, smart dimension. The reason why I'm saying we're doing smart dimension is just look at this example. So currently it's giving it as a radius, but this is just a parameter. It's not defining the sketch. So even if I make this parameter 50 as an example, let's rather do 40, it'll still be blue because there's nothing that shows that this is defining the sketch, and anyone can easily go and move this. But if I use my smart dimension, this will now actually fully define that sketch. Okay. So again, notice that the center circle is also black. My entire sketch is still a fully defined sketch. And because that tick box was on for a diameter dimension, it'll actually do it as a diameter. But here's the important thing. Let me just make this a little bit smaller. If I decide, okay, now this is now my diameter, and I rather want to go and change this, you can click on that dimension, and you have here on your left-hand side, first of all, you have all of your tolerancing types, minimum, maximum, if that's applicable in your industry. And you can also go and change the precision. So the precision is just basically how close to that specific zero should I get. That is most of the time we accept a 2 decimal or a 3 decimal. Okay. When I go to my leaders, this is where I can actually go and decide how the dimension will define itself. Should it be a radius or should it be a diameter? And if I click on radius, it'll actually change that to 40. And again, I can click diameter, it'll just chop and change between the two. Okay, so it's not defined that you have to use diameter or you have to use radius. Per dimension, you can actually go and change it. Okay, let me delete this dimension. So one of the main questions that normally come out as well is if I want to do a dimension, so I don't have to dimension from a point to a point. Like this example where it's currently 100, I can either do point to point, yes, that is fine, or I can just select a line. So that line will always then select the entire entity. The reason why this is a driven dimension is because I already fully define it with this 100. But just to show you, so if I delete the 100, I just put that in, you'll see there. Again, it's fully defined. The reason why it is fully defined is due to the fact that it actually goes through your center line. But now as an example, I want to maybe dimension between the edge and the circle. I don't know maybe what is the exact dimension of the circle, or when I didn't have that dimension, I'm not sure. So if I click the line and the circle, it'll automatically snap to the center point of the circle. But what if I want to do the arc to the line? So again, so if you're holding your shift and the line, it'll actually be an outer arc dimension to the edge of the sketch. Again, shift will be the outer perimeter, and if you just click, it'll always go to the center perimeter. So you can also do this between two different circles. So you can shift click the two arcs, it'll actually give you the dimension between the arcs and not the dimension between the centers of the part. So just keep that in mind. Okay. So it's just a quick tip on dimensioning. What I can also show you is the other options. So I showed you now a rectangle and a circle, and also notice that you have lines. So I can have a line. So again, this is a click operation, and then this line will actually continue as I click with it. But sometimes maybe I only want one line. So how to do that is also, you can just hold in your shift command drag and drop, it'll actually create it. Or you can just drag, so click, hold in your mouse cursor, drag it, release it, it'll do actually entities. It won't create one long line. Okay, so just keep that in mind when actually drawing. And if you drew where you did a click function and you want to stop, you can just press your escape button or right click and say select. So if I was actually in a sketch, I could have done that. So how can I now go and delete these lines that I'm not using? This could actually be quite a tedious process. I can go and select everyone. I can maybe do Control Z. But we have an option for trim. And what the trim does is, the power trim option is I can just go and drag my mouse through all of them. So I can actually go and delete the ones that I don't want to use. So the power trim is quite a nice feature that I can go through. Even if I had a sketch through my part, let's say I had that and I have a line there, I can use my trim tool and I can just go and trim specific pieces of my sketch. So this would have been quite difficult to go and draw if we didn't use our trim tool. So always rather try and make the entire thing and then go and take away what you don't need. There is actually a way that I can do this with a circle. That is called a perimeter circle. So in my different options is I've got a center point arc or the tangent or a 3-point. And in this example, what I'm going to show you is just the center point arc. So again, you'll notice it's 3 clicks. First click is on your center point. Second click is where do I want to start. And the third click is where do I want to stop. So exactly in this same scenario, click on the center. Maybe I want to go just from there. Click, go around, and click again. So that is what is called a center point circle. The other options you can go through yourself, but just like a 3-point arc is, I can maybe just click on that edge, decide how big I want this arc to be, and it could be an arc like that. And then again, I can just go and trim out pieces that I don't want to use. So they might be. And now also remember, this is now a blue sketch. So if I give this to someone else and I ask them, go and design this for me, it is there's no way that someone else can actually go and design this without making slight adjustments or problems in it. So again, use your smart dimension. Go and smart dimension your different options like this. You can smart dimension the arc. So this will maybe be 30. I can smart dimension this to be 40. And you'll notice all of the lines start to become black. If a line is still blue, it means that that line can actually move around. So even this one, make it 50. Now I'll notice that all of them, except this top one, I'll make that 30 as well. Okay. So again, due to the fact that this is just an arc and I just give it a dimension, I can still go and move this around. Nothing is putting that in place. So what you can do is you can also use, if you control select them, you can have relations. So relation in SolidWorks is almost like a dimension, but I can tell, okay, these two lines, you must be horizontal to each other. Or these two lines or these 2 points, they must be vertical to each other. And in my example, I'm just going to make them horizontal. So both lines or both points are now in line. And this is a fully defined sketch. Okay, so there's quite a few options available. And then just some of the other options is, for example, convert entities. If I want to reuse a specific one already used in another sketch, I can actually select convert entities and it will create that sketch on a part for me. So that is just some of the options. Offset as well. I can go and select some of the lines and I can go and create an offset of those 2 lines and create them. So offset is take the exact same line and just make it 10 millimeters to the side or to the inside or the outside. So there's actually quite a few options that everyone can use through the design process. The last thing that I just want to quickly show you is you can also do mirror entities. So if this was quite tedious to go and design, I can either use mirror or linear sketch pattern. What I will do is it'll actually take that entire sketch and duplicate it to the side, or it'll just flip it over the edge. So I'm going to use mirror. what do I want to mirror? I can just multi-select all of them and then mirror about. I can use this edge as an example, and it will make an exact replica of that onto the other side. Okay, so these ones are now a few sketches that are actually going through each other. You can either do that, or then with the linear sketch option, I can maybe take this and I can go and select, okay, I want to copy these 4 lines, make it 5 lines, and just give it a dimension. So I just want to take this, add that on as well. So it'll just take that entire sketch and just make a copy of it to the side. Okay, so next week we'll go into more detail on these sketching, and then also what you can do with the sketch with your different types of extrusions and how you can reuse sketches. Remember, you can actually copy and paste the sketch from one part to the other part. Okay, so that is the more advanced stuff, and I'll show you that next week. I'm going to give over to Eva now. He's going to show you some of the basics of simulation, as you already have simulation in your package. So let me stop my share.
Thank you, Pierre.
Eva, you can take over.
Okay, so guys, welcome to our webinar. Just checking that everyone's still there, that the chat's working. Let me just open up my chat here again. Okay, so I will be walking you guys through just how to get started with simulation, giving you some tips, and I'll also talk about what simulation is, why guys might want to use it, and a few other topics. So SolidWorks simulation is, and let me just back up here. So it's what we call a finite element method solver. So what that means is whenever you have a specific design and you want to calculate the stress and how much the piece is going to bend, there's a bunch of calculations you can do yourself. Now, these calculations are only defined for very simple designs. So just a plate or a beam or a plate with a single hole in it. But as your designs get more complex, it's very difficult to create a hand calc for these. And even if you had one, it would take you very long to work through it. So if you had a plate like this with 3 holes, you'd have a really difficult time to try and do a hand calc for this. So what we do is we do finite element method. And with that, we take that plate, divide it into much smaller sections. So these little triangles, divided up in a process we call meshing. And then we do those calculations we do by hand. We have the computer do them on each one of these triangles. And then it can tell us what these stresses and everything are in that part. Now, you can do this for stress deformation, but you can also do this for things like what's the frequency this is going to vibrate at? Is this part going to break after X many cycles? What's the temperature in this part, et cetera, et cetera. So there's a lot you can do with this. And there's also flow simulation, and we'll talk about that another time as well. Now, why would you use SolidWorks simulation specifically? Well, SolidWorks simulation, because it's directly linked to your CAD, and because SolidWorks is one of the world's biggest CAD packages, everything you draw, you don't have to go and redo anything in a simulation package. Everything gets pulled in right through directly into your simulation site. And also SolidWorks simulation is within, or actually less than, the worst case result is less than 1% away from the expected result for benchmark simulations. And those are simulations you do to check the accuracy of a simulation package and so forth. So I'm going to get you guys just started on how to work with your simulation. Let me just show you this quick example here. So this is just a basic simulation. This part isn't actually moving. This is just an animation of the deflection this part would experience under the load. So when you have a part, let me open up my SolidWorks here. So I'm going to start with a new part. And I'm just going to draw a quick plate, maybe use some of those tips Pierre was using with sketching. So I'm going to use a center plate. Let's give it some holes. And then add some tangent arcs near the end. Use this arc option. Okay, and like Pierre mentioned, you can trim things away. I like using this keep trimmed entities as construction geometry. So when you trim it, it keeps the line there, but it's now not part of the main extrusion sketch. So I'm just going to quickly extrude this. And there we go. Okay. So to start using your simulation, you're going to want to turn on the simulation add-in. Now, there's two places you can do it. There's the SolidWorks add-in option here, and you can start simulation straight from there. Or there's an add-ins option here at the top, and you can just tick that box. And if you want to always have it on, you can tick the startup option here. Note when you tick on options, it takes longer for SolidWorks to start up. So just be careful what you turn on. So using this part, just waiting for the simulation add-in to load. Okay, there we go. So there's a few ways you can create simulations. You can start directly with the simulation you want, if you know how to do it. So you can say new study and select the type of simulation you want to do. This is more for if you know how to do that simulation and you know how to set everything up. But what I want to show you guys is the Simulation Advisor. Now, this is a really cool tool, especially if you haven't done simulations before, you're not sure what to do. This will walk you through getting started, setting up your simulation, making sure you've done all the right things, etc. So first off, it just asks you, okay, what are you worried about? Why do you want to simulate this? In our case, we're worried about excessive deformation or stresses. There's a few other options here. You can look at some like temperature, shaking, etc. And then it'll ask you some options. I'm just going to click next. And then it's going to create the static study for me. Now here I have my static study. In the simulations option, you'll see everything works either from left to right or top to bottom. And that's how you work through a simulation. So you'll start from the left, you'll apply a material, you'll add your fixtures, add loads, specify connectors such as bolts, welds, no penetration contacts, etc., springs as well. And then you can run your study. So the same applies here. Obviously, they also have the meshing option here. So for that, I'm going to switch to the bodies option. And the first thing it's going to ask me is there any symmetry conditions? So I'm going to tell it no, because there's no symmetry here. Just going to click next here, and I'm going to choose a material. So when you click that, it'll pop up with the material option. Let's use an AISI 1020. So that's a typical mild steel you'll see. I'm just going to keep going. Next, interactions. So you can skip this section, or you can have it guide you. In my case, I'm just going to do those interactions on my own. So I'm fixing this face here, and I'm going to apply a force on this edge, and I'm going to give it a selected direction. So I'm going to select this face and tell it, okay, push on that face in that direction with 700 newtons. I'm going to select OK. Okay, so again, here's the interactions option. I'm just going to skip through to the mesh option. So the mesh option is going to ask you, okay, let's have a look at our mesh. You'll see here at the top, it talks about interference. And it's a topic we'll cover on another day. So when you mesh, you'll see you specify how fine the mesh needs to be. So I'm just going to use the standard mesh. And you can see what my mesh looks like. Now, when you do a simulation, you want at least 2 elements through thickness. Now, this is considered 1 because the element bridges directly from one side to the other. So I'm going to change my meshing parameters, make it a bit more fine, and see what I end up with. So you'll see here I have at least 3 elements through thickness. This might be too much, or so I might want to reduce this, but I'm happy with this. I'm going to go ahead with that. So next, I'm just going to run this. And the simulation will run here. Keep in mind, simulations are very processor heavy. So if you have like an i3 or Celeron, you're going to struggle running simulations. If you have an i5, one of the new Ryzen processors, like the Ryzen 5, 7, or 9, or the i9s, then these simulations run very easily. But there's still tricks you can do to have them run fairly fast. So you'll see here the shape, it's showing me the deformed shape. Note the deformation scale up here. So that means it is exaggerating how far it's deforming by a factor of 7.4. So 7.4 times more than it would actually deform. If I show you guys the stress plot and also just a displacement plot. Now here on the left-hand side, it'll walk you through the results, because there's an important part in simulation. It's just checking, is what I'm seeing actually real, or is it, have I done something wrong? So it'll ask you here, does the deformation shape look good? Now, in my case, everything looks good. It's deforming how I would expect it to deform. So I'm going to say everything looks reasonable. Then we're going to go and it's going to ask you, okay, other results concerned. Is it breaking or above the yield point? You can see here what the yield point is, and we are below that. And so we're happy with that. So we can just say finished with result advisor. And that's just a quick and easy way you can make use of simulations. There's obviously a lot of other tools that we can cover at a later point. There are simulation tutorials. So if you go to, let's just see here, simulation help tutorials, a window like this should pop up, and it'll guide you through the different packages and what simulation tutorials. So you can start with these basic ones for static analysis, and there's a lot more available to you. So I'm going to go back to everything here. I'm going to talk just a little bit about the theory behind simulation and the study we just did. So I did what we call a static study. Now, you get two main types of FEA simulation. You get static and nonlinear. Now, what the difference between these two mean, and static and nonlinear are other words for linear versus nonlinear. Linear just means it is either linear geometrically in its boundary conditions, or it is linear in its material. Now, what that means for geometry, that means just nothing is changing. It's not moving. Unlike this part over here, you can see everything is moving. This is a nonlinear geometry, where static geometry, it's not deforming a lot, you're not bending it a lot like a piece of plastic or rubber. It's behaving normally. So when you run a study, just be careful which type you try and run between these two. Next, you get the material nonlinearity. So what this means is, are you in the linear region of the material, or are you in the nonlinear region? Now, some of you might be familiar with the stress strain graphs. Some of you might have worked with them before. So everything up to the yield point is the linear region. So for steels and aluminium, that'll usually be 0.2% strain. For plastics and rubber, that's a slightly different value, but usually plastics and rubber are very quickly become nonlinear. Now, SolidWorks has a bunch of different nonlinear model options or material properties. So there's the basic ones for plasticity, elasticity, etc. Things like Drucker-Prager is a specific one for soils or dirt or anything like that that's only in the compression type of state. There's nitinol, which is memory alloys, viscoelastic. There's a bunch of different options you can play with. A very powerful CAD package. And just some of the graphs of nonlinearity. I'm not going to talk through those. And this is just an example of material nonlinearity. That is a rubber seal being compressed. Okay. Lastly, you get boundary condition nonlinearity. What this means is any forces or fixtures that are being applied are not applied, if they're applied non-linearly, they're being applied over time. So it'll be where you push something and then maybe take that away. Where a static analysis, all the force from the get-go is being applied. So this is also another distinction of linear versus nonlinear. And here, just an example of a nonlinear simulation in SolidWorks. And just a simple example I made. Okay. An important part of simulation is knowing if everything is accurate and the results you are seeing are true to life. Now, that all comes down to knowing what assumptions you've made. Simulation is a method of approximating real-world phenomenon, and thus, because you are approximating, you are making several assumptions. You have to know what assumptions you are making and if they actually apply. So the whole process of simulation validation is just reviewing your assumptions and seeing if they are correct. Here's a bunch of different assumptions. Like I mentioned, is the geometry actually realistic? Is it changing, etc.? There's a bunch of different other ones here. Things like does it deform in the shape you expect it to deform? Obviously, you guys can go through these when we send you the slides, but these are the general steps and also the order you'll go through them. So starting at the left from here and going through there, just checking that everything is working, everything is fine. Now, in simulation, there's several other simulation options. So in SolidWorks, you have motion simulation. So this is similar to your atoms. In fact, SolidWorks Motion actually uses atoms as the back end and uses SolidWorks as assembly mates and everything to run everything. So you'll see some examples here. And let me play this one over here. So this is a catapult with gears, pulleys, friction, etc., and also several types of contacts. So you can actually do quite complex mechanical rigid body simulations with this. There's also a flow simulation. So SolidWorks has a built-in flow simulation tool, something you guys all have access to. And it's quite advanced. You can do quite some complex things with it, complex things as well with it. So definitely consider this as well. Lastly, now this isn't the video, it's just an image of plastic simulation. So this plastics is for plastic injection molding. So you guys that are designing more organic shaped, designing things that would be injection molded in the end, really powerful tools. Usually injection mold can easily cost 100,000 Rand or more. So simulating whether it actually will give you accurate results is really important. So you can simulate, is the ejection going to completely fill the mold? Is it going to warp afterwards? Where do my cooling channels need to be, etc.? There's a lot of options with the simulation. Now, I know I went a bit fast, so if you guys have any questions, just type them in the chat box, and we will try and answer them. Also, please guys, fill out the attendance form and feedback form with either this link here or this QR code. Your lecturers have asked us just to track attendance, and so we send them the attendance record in the end. Yes, everything is being recorded, and so we will send you the recording in the end. Let me also just give you guys this link over here in the chat. So that's so any questions from you guys? Anything in terms of simulation you want to ask or sketching?
Okay, doesn't look like there's questions coming through. You can use this, or you can use that this attendance feedback form, and then you can just ask the questions on that side, and we'll respond to that.
Guys, you can also, I think 1 or 2 webinars back, someone asked about simulation and just they wanted to ask me some specific questions. Just talk to your lecturer, put them in touch with us, and then we'll try and address any specific questions you might have if your lecturer doesn't have the answer on their side. So let's see here. Okay, so some guys want to see stuff about assembly, so we'll see about doing that sometimes.
Okay.
Now, guys, please do not annotate on make any annotations on the screen. Some guys are saying the link is not working. Let me have a look. Let's see. Let's just close this. Do note it has to be an uppercase M when you type in MECAD. So that might be why it's not working. Yeah, so unless there's any questions, this will be it for today's webinar. We'll obviously stay on for maybe additional 2 or 3 minutes to see if anyone has any questions. But yeah, so sketching and simulation.
Thank you, everyone. You must all enjoy your weekend, and we'll see you next week again. Remember, you can go and link us on our website or LinkedIn page, as well as our YouTube channel with the MECAD Minute hashtag. Go and join and subscribe there, and you'll get updates with all of our events and everything for the webinars.
Next week should be the same time, but we will talk to your lecturers if the time changes, and we will send the links and everything to them.
We will also add these recordings onto our YouTube channel. We're busy setting that up for everyone, that you can go and download or watch it straight from there. Okay, that's all. That's everything for today. Thanks, Irfan. Thanks, everyone. You must enjoy your weekend.
Cheers, guys. Enjoy your weekend.